to the Environmental and Water Resources Podcast in the Civil and Environmental Engineering Department at Colorado State University, brought to you by the Environmental and Water Resources Institute at Colorado State University, where we get to know CSU professors, water environmental professionals, and learn about their work. I'll be one of your hosts today. My name is Ben Schote. I'm a PhD student at CSU and the current president of EWRI-CSU.
I'm your other host, Joe Pugh. I am a master's student in civil engineering and the finance chair for EWRI.
So today we'll be speaking with Dr. Aditi Bhaskar. She's an assistant professor in the Department of Civil and Environmental Engineering at Colorado State. She received her BS in Environmental Geology and Physics and Math from Brown University, and received a PhD in Environmental Engineering at the University of Maryland, Baltimore County, where her dissertation title was Effects of Urbanization on Groundwater Flow Systems and Stream Flow Generation. She currently sits on the board of directors for the Consortium of Universities for the Advancement of Hydrologic Science, or QUASI, and is the faculty advisor for EWRI at CSU. So Aditi, thank you very much for speaking with us today. How's it going?
Glad to be the inaugural podcast visitor.
Yeah, it's very exciting. Yeah, thank you very much for agreeing to do this. So this is our first podcast, and it felt very appropriate to have our faculty advisor on. So we're hoping this all goes well, and there'll be many more to come. So let's just get started. Maybe can you just tell us a little bit about your background? Just really anything you think you'd like to share.
Yeah, my background, you said my educational background. I've been here at CSU since 2016 in civil and environmental engineering, work on urban hydrology topics. I grew up in Maryland, outside of Washington, D.C., in a suburban area. And yeah, this is some forest area, also some stormwater in the suburbs. And so that was a little activity when I was growing up, crawling through the stormwater pipes with a little backpack, flashlight, granola bars. So that's come back a little bit. I don't crawl through them, but
Actually, I think I do have a photo of you crawling through a stormwater drain, or maybe you have a photo. One of us have a photo of the other one crawling through some stormwater down near Denver when we visited with the Right Water folks.
Oh, okay. In the culvert in Parker. Okay.
Yeah, exactly.
So Aditi, we wanted to ask a few casual questions just to get to know you a little bit better. And you can kind of take your pick of which one of these you want to answer. But we were wondering if you have a first concert or memorable event that you remember that sort of maybe captures your personality at all.
Yeah, I was reading this question. It was really hard for me to even remember that there were concerts.
Yeah, what's that time?
A time long ago.
I know, I can't even remember. Like, before pandemic. So unfortunately, I can't even remember any.
How about any hobbies that you enjoy?
Yeah, hobbies have been, I wouldn't say very consistent hobbies. I was sort of gardening this summer. I thought I would garden more with the pandemic being at home, but that was less than I thought. I got out my sewing machine for the first time since I moved to Colorado this summer also.
Nice.
I thought I was going to make masks, but actually just repaired clothing and made curtains. Walking around, hiking.
And do you have any favorite restaurants in Fort Collins? Anywhere you'd recommend to eat?
Also a pandemic challenge. It's because I've been eating at home pretty much all the time. Although I did get takeout from restaurant 415. And then I thought, oh, I I remembered Ruska on Laurel,
Mm-hmm.
the Ethiopian restaurant on Laurel. And I haven't been there during pandemic. I haven't eaten a lot of different foods during pandemic because I just go based on what is delivering. But other places are doing takeout, and I should go get takeout.
Yeah.
Yeah.
You said restaurant 415. Is that on Mason there?
It is on Mason. It's yeah. There were a lot of people eating inside, and I went to it. Yeah.
You mentioned some hiking. Are there any spots around Fort Collins that you like to go hike? Are you like mostly you like to walk in the flat part, like the eastern part of town, or are you like to get some elevation gain?
More flat, I would say. Well, I just mostly walk around, mainly I walk around my neighborhood in City Park. My favorite hike right near Fort Collins is Red Mountain Open Space, which is pretty flat, which is an hour north because of the red. A lot of people are in the mountains. The mountains are nice. It's just very green. Not now, but most of the time it's green. And so for some reason, since moving from Maryland to Colorado, I've been appreciating a little drier places. So, yeah, like prairie, kind of red areas.
Yeah, that Red Mountain Open Space, it almost feels like Mars or something when you're up there.
Yeah. Yeah, Mars, and then it has some little geology, what do you call it? Signage.
Yeah. Mm-hmm.
Cool. Yeah, I'm actually not sure. I know where y'all are talking about. Is that right near town?
It's an hour north.
Okay.
And it's next to, it's a Larimer County place. And then there's a city of Fort Collins.
Yeah,
park
Soapstone.
Right next to Soapstone Prairie. Okay, yeah. Right next to it. It's on the border of Wyoming.
Cool.
Mm-hmm.
Just north, basically.
I'll have to check it out.
It's usually pretty sparsely populated.
There's not a lot of people. Also, there's no dogs, so that's another reason why you may not have down there. I don't know.
Probably so. I don't do anything where the dogs can't come in.
Yeah.
Cool. So yeah, maybe let's transition a little bit into your kind of professional or academic, interests and passions. I guess broadly, how do you characterize your field of expertise, or how do you kind of identify as a water or environmental professional? How do you kind of describe yourself to people professionally?
Yeah, I work on water resources and the urban environment, maybe a little bit broader land use change, but mainly with urban development and water resources. So this is a couple different areas within, since there are multiple processes going on with urban development that affect water resources. So stormwater management, but also looking at outdoor water use and water demand questions as they affect stream flow, flooding, base flow, groundwater, parts of the hydrologic cycle.
Awesome. I guess I can take a minute. So I'm actually, Aditi is my advisor, so I have a lot of the very similar interests and really share a lot of those same passions and interests. So I guess I'm biased towards them. Really, really great interests.
I agree.
Yeah. So like when you come to work on a daily basis, or I guess these days when you go to your home office on a daily basis, is there anything in particular as far as aspects of work or research that really get you more excited or kind of really, motivate you in the mornings?
Lately, I'm teaching this is maybe not research focused, but something that's new with me this semester is I'm teaching a class, a flipped class since I'm teaching basic hydrology all online on Zoom this semester. So I'm recording all these lectures for the class outside of class time. And then I do breakout rooms with them during class and work on homework so they can work on homework during class time and ask questions. And so that's, I don't know if exciting is the right word, but it's definitely motivating because I need to keep up with recording all the material in outside of class time. But I have been, everybody, I think we all have been getting a really rapid introduction to all kinds of technology. I've seen it here and getting more well-versed in, you know, and familiar with recording videos and writing on my iPad as a whiteboard and YouTube. Yeah, more broadly, I've been stuck on that kind of some of these pandemic challenges, but they're also, yeah, more broadly, there's just large scale challenges we're seeing. I mean, we're seeing the smoke, which is related to climate change and will likely affect our water coming up soon when we get some precipitation, water supply wise, and then flooding wise potentially. So lots of challenges going on that we can hopefully, as environmental water resource professionals, contribute to solutions.
Definitely. Yeah, that actually, take another little side note to anybody listening. We're recording this on October 19th, 2020, and we've had some wildfires here near Fort Collins burning for the past 2 months or so. I guess a little over 2 months now. And depending on how the wind blows any given day, we can actually have some pretty severe smoke these days. But today seems to be a little bit better than others. Yeah, so lots of challenges coming from that, it sounds like, and hopefully lots of opportunities, like you're saying, as you know, environmental water resource researchers, professionals, to hopefully help out with those challenges going forward. So I guess maybe taking a step back and being well aware that not everybody, you know, knows what their dream job is when they're 5, but maybe say something a little bit about what led you down your path to where you are now. Were there certain specific instances that maybe guided you this way, or just kind of came to you along your path, or kind of how did you end up where you are? What brought you here?
Yeah, I wish I can remember this magazine article. So when I was in high school, I was taking physics, Mr. Schaefer's class in physics, and he was fresh out of college and very enthusiastic, and I enjoyed the class, but I really couldn't, because it was high school physics, we really didn't get into any applications. And I thought, this is so theoretical. It's fun to work on, but it seems pointless. I mean, no offense to physics, there's a lot of applications and use of physics, but I couldn't see the applications. And then for some reason, I read an article, I think it was in like National Geographic or something. And then I heard about groundwater, and I really didn't know much about groundwater before reading this article, and I read about groundwater in this article and then found out that, as I saw it at the time, this was an application of physics principles to something that I could see a societal use for. So I just latched onto that and decided I wanted to work on groundwater. But I was a little bit misguided because I then went to college, and I thought for some reason that I should be a geophysics major in college to work on groundwater, and that really was not accurate in terms of a good major to choose, because at least the program that I was in, it was a great program in a lot of ways, except for it really didn't have water as a focus at all. And so the geophysics is a very, there are components of geophysics that intersect with hydrology, but the kinds of topics that the program that I was in focused on was really kind of solid earth geophysics and mantle convection and seismology. And so I didn't realize what I was getting into and was a little off track to what I wanted to work on, although I got a lot of math and physics and geology, which and fluids. So those were all relevant, but not what I really wanted to do. And then I kind of did a little course correction in grad school where I was able to switch into a program or go from a geoscience program to an environmental engineering program that was more targeted towards what I wanted to work on. And one of my main motivations is I wanted to work on a topic where I felt like I could see how this could be of service. And so working on urban areas seemed that was more clear to me maybe than in other topics, although you know, there's different degrees of, you know, how theoretical or how applied work is, and some things might take a while to make it into practice to make a big effect. Other things might be you know, more directly applicable but smaller steps. But I wanted to do something where I could see the connections to the societal use of this work. So I started working on this project at University of Maryland, Baltimore County for grad school, which was it was associated with, at that time, the long-term ecological research site. The Baltimore Ecosystem Study was hosted at University of Maryland, Baltimore County. So there was a big group of urban environmental or ecology researchers and some hydrologists. And I was working on a project with urban hydrologists interfacing with other researchers. So yeah, since I came to CSU, I've been in the same general research area, but shifted towards semi-arid and arid regions, which has been, compared to when I was in graduate school and a postdoc. So yeah, when I was a postdoc, I decided I wanted to do something more focused on green infrastructure in these experimental watersheds, also in Maryland. Yeah, since coming to Colorado and reading the Colorado Water Plan when I first came to Colorado had a big effect on me. Just seeing that conveyed to me just how dire the water supply demand gap situation was. The projections, the quantity issues were way outside of what I had ever been exposed to on the East Coast. And so I felt like this is something hopefully, you know, we can contribute to, because yeah, there's just there are very large gaps that are projected for 2050 in that water plan.
Yeah, reading that water plan is, I'm from the Midwest, and that's from Kentucky, and you know, we have plenty of water there, no need for irrigation or stuff like that. So it was a pretty stark realization of just how finely tuned our allocation systems need to be in order to support population growth and all these industries and stuff like that. Are any of your current projects right now kind of tackling that question of how to think about urban water management in these semi-arid regions?
Yeah, so current projects. So Noelle Philo graduated in the spring of this year. And so she was working on lawn irrigation return flows in the Denver area. And so that's quantifying those using water stable isotopes. So that's related in that it's a potential unintended consequence of changing urban water demand, particularly the outdoor part. What might that do to stream flow as an potential unintended consequence for drying up urban streams? Yeah, Ben's been working on a project that's more multi-city, so not specifically semi-arid or arid, but we have plans for focusing on the Denver area. There's a rich set of stream gauges in the Denver area, and then another project is looking at kind of grassland, rangeland development into urban, suburban landscapes, and how stream flow changes with development and also green infrastructure.
That's fascinating.
Yeah. So I guess kind of along the same lines, but if you had to kind of step out a little bit and just consider kind of your field as a whole, which maybe if we had to pick a couple of words, maybe let's start there. We kind of already said this, but if you had to like really be concise in like 2 or 3 words and say what's your field, for example, maybe it's like urban hydrology or something like that. How might you? What words, few words might you use to classify your field?
Oh, if I introduce myself as a hydrologist, if people know what that is, that's how I describe myself. Some people don't know what that is, so then I just say water scientist or something.
Cool. So yeah, so if you had to kind of take a step back from that, under that umbrella, are there specific challenges or kind of pressing issues? You've mentioned a couple specific here, and it's not really specific, I guess, only to Colorado, but all arid environments, but this kind of supply-demand gap. But kind of more broadly, are there specific challenges or pressing issues that come to mind or that you think about?
Yeah, so yeah, there are many different challenges and issues. So yeah, one is, I mean, I would say 2 categories maybe are ways that our world is changing, and one way that our world is changing is through urbanization or land cover change in general. So any kind of land cover shifts. Urbanization is an extreme one in terms of the effects that it has on stream flow compared to other types of land cover change. It has a very noticeable, obvious effect on stream flow, but urbanization actually affects a relatively small land area directly versus other types of transitions between forests, agriculture, grassland kinds of transitions affect much more large areas, although the hydrologic effects might be more, maybe less obvious. And urbanization also has effects that maybe are easier to recognize compared to climate change on hydrology, although climate change is affecting every single watershed on the whole planet versus urbanization is affecting maybe a subset of those concentrated around population centers directly, although urban areas affect many other places because they use other places as rural areas as source waters and supply. And so yeah, climate change is a challenge in that, I mean, multiple challenges, just the whole fundamental challenge of non-stationarity, of not being able to use our historical records to predict what's coming with precipitation and temperature shifts, what kinds of shifts we might see, how that might affect water supply availability, and also potentially water demand. So it could affect both of those. So yeah, there's lots of unknowns in there. Then we also have, so those are shifts that are happening, changes that are how our world is changing. Even in our current situation, there's other challenges, even if our world was staying the same, in that we have this set of places that we're collecting data hydrologic data, and we have, for example, stream gauges, and then other places we might be collecting information on that we can use to calculate evapotranspiration or precipitation, but there's components that of the hydrologic cycle we really don't know much information about. And then there's vast areas that we really don't have data on. I mean, just a small subset of places have stream gauges, and that's usually our, a tightly constrained part of the water balance. And then there's other parts that are not well constrained at all. We had this paper come out in Water Resources Research led by Stephanie Camp earlier this year about, and a component of that was the interbasin transfers, and how hydrologically important they could be, but how we just don't have in the US good records on where and how much and which basins have interbasin transfers. So that can be, close to, it could, that can be a really major component, like the largest outflow of the watershed.
Just to clarify real quick, by interbasin transfers, are you talking about groundwater flows between basins?
I was actually, there could be groundwater flows between basins, but that usually wouldn't be called a transfer. That would just be, that would be subsurface, movement in or out that you could have, which also can be very large component of the water balance, depending on what kind of watershed you're looking at in that scale. But here I'm talking about water, like in Fort Collins, we use water from the Colorado River Basin across the Continental Divide. And so that's an interbasin transfer. So water that is being transferred by people for water use in another watershed. And so that's, for some watersheds, maybe the dominant, maybe larger than stream flow as a component of the water balance, and affects, a whole set of watersheds, especially in the Western US. So it's just a challenge to keep long-term monitoring going of all these different data streams, and still we only have them in a limited number of places. So other types of places we don't have much information on, never mind for kind of shifting conditions. Like there are not that many stream gauges in intermittent and ephemeral streams, or kind of at lower elevations in Colorado, other than the big rivers. And so we don't quite know what stream flow would look like in a grassland in Colorado too well, because there's almost no stream gauges anywhere.
Yeah, I think that's kind of an underestimated factor of a lot of the science we do is, how good are the measurements we take, and then how, sufficient are they at characterizing sort of the environment we're trying to study. I think there can be a lot of work done in our field with improving those measurement strategies, sort of shrinking down the uncertainty that's inherently built into any given data point, and then also figuring out ways we can spread that more efficiently, more cost effectively, so we just can measure more points. And then obviously across every discipline there's that question of data management, and when you do yield large sets of data, you always need somebody to be there to sort of sift through it and organize it well and store it efficiently. So
I'm very reliant, and multiple research projects are very reliant on the USGS, US Geological Survey stream gauging program. And so that's important, just keeping, that requires funding to keep that going. And so that's very important for, we did this analysis that came out earlier this year on these stream gauge records. Some of them go back to the 1940s, and during urbanization, as a watershed is going through this transition. And, we did this retroactively, to look back in time over decades at these places, and they weren't put in to capture that kind of analysis I'm doing, but because they were recording stream flow over these decades, we could do this kind of analysis. But we only had, we just didn't have these kinds of long-term records everywhere we wanted them. That's always a limitation. We want to learn about other types of places, other types of watersheds, other types of climates, soils, geologies, urban development patterns, how they would look, because they're not all, basically we found that there's so many differences. This effect of urbanization is not consistent in different places.
Yeah, that's something I didn't have a full appreciation for until probably this past year even. I took a couple of classes where there was some interest in looking at more international data sets, and we were kind of used to having access to these data sets that are present in the US, which we're sitting here saying often aren't even as much as we need. But it really seemed like compared to a lot of areas, we're pretty well off with our, the richness of our data here. I had a couple of follow-up questions I wanted to get at real fast. One is kind of getting at climate change, not necessarily large scale, but maybe if you're looking at a catchment, or just kind of generally. I know that you talked a lot about empirical studies. That's kind of what we were talking about, having this data sets to look at. I know that you've also done some watershed modeling in your past and for your PhD dissertation and stuff. And I'm wondering if you have thoughts on kind of reconciling the empirical studies and modeling as a way to, kind of get at how we can expect things to change, or how do those two kind of types of studies mesh, have empirical versus modeling? And I guess modeling is also very vague. So I'm specifically referring, I guess, to more like physical watershed modeling or computational versus statistical.
Yeah, so climate change is, I was mentioning we were looking at these historical records to look at times of urbanization and watersheds and how stream flow changed over those times. And we can look back in stream flow records to try and look at that urbanization signal, because urbanization is this process that has been going on for a while. And so we have records on that process, watersheds transitioning, and we can observe stream flow during that transition. Climate change is challenging in that we can see rising temperatures, but it's hard to detect the effect of precipitation on, because, as from climate change and separately from the interannual variability, which is already so large, and the effects of that on stream flow, because in the current moment when climate change is ongoing, it's not like urbanization where we can say this watershed developed already in this previous time period, and now we're able to see pre-development, during, and after. Like, we're in this experiment right now. It's a long-term experiment. We're in the middle of it. We're like in the during period. We don't have the and it's not like a confined time period like urbanization. It's continuing to go on. And so we don't have, just with empirical records, it's actually very challenging to see the effect of climate change on stream flow, because there's so much interannual variability. There's so much basically randomness in stream flow that it's hard to really say to really separate in a statistical way that we're seeing the effect of climate change. It's clear that there is an effect on climate change, on our hydrologic system, but to really be able to isolate in a quantitative way, this is our current observed effect, we can't quite do that yet. We will be able to do that maybe decades in the future, looking back into the past. We will be able to say this was the effect of climate change on stream flow, but you can't do that yet. And we don't want to wait until then to say this was the effect. And so that's where models come in, because we cannot, with empirical data, we are limited, we're completely limited to the world we have right now and the past world. We cannot observe anything that either hasn't happened or alternative scenarios of the present conditions. So that's a key role of modeling is we don't know, there's models have their own, they need to have their own inbuilt assumptions, and those might lead to limitations, but we really have no other way to understand what might evolve in the future without using models, because we just don't have empirical observations in the future.
Yeah. So you think that both those are essential parts of the toolbox?
They are, and depending on what kinds of questions you want to understand, if you want to understand something which you can observe this effect, then of course just observing the effect directly is going to be the most effective way, because you're not going to be needing to parameterize a model and put values that you might have a lot of uncertainty about. But actually there are not a lot of things that we might be, there are some things, but they're limited, the kinds of things which we can directly isolate them in natural watersheds. In this kind of situation, we're not able to really do experiments, so we can't control one variable. We're just limited to what's happened already. And so maybe multiple things have been happening simultaneously. There's urbanization, there's climate randomness going on. And so we're trying to maybe look at one of those factors. And so we can do that with empirical data, but there are many things that we're interested in that we really can't observe the effect of that factor changing. And that's where the development and, in hydrology, models have been becoming more and more sophisticated to be able to really get at physical processes, the best of our understanding of the theoretical basis of water flow in surface and subsurface and interactions, and be able to represent that in a model to really isolate the effects of particular variables or look at future conditions that we haven't observed. So they're both important.
Yeah, I think using those together presents a lot of hope for our field and just furthering our understanding as as you mentioned, as our models get more sophisticated, they're able to capture those physical processes to a higher degree of certainty, if you will. But there's always that pitfall, if you will, of trusting the model too much, and you always need some empirical data to go back to and make sure you're training your model and not extrapolating out too far into the future with your model. So as we mentioned before, as our methods for gathering empirical data, if those can improve with model sophistication, we can sort of train those up together. I think, like I said, that offers a lot of hope for accelerating our understanding, and then with that, our ability to make decisions on a timely basis.
Definitely.
Yeah.
So I have one more follow-up I wanted to ask you, Aditi. You kind of got at, you mentioned kind of passing the challenge. You moved to Colorado, and you mentioned how it was like challenging to even know what kind of a undeveloped watershed in this area might even look like, because there's just so few of them. And I know, because I work with you and familiar with some of the challenges you face sometimes, that I guess a quick preface maybe is the idea of doing these comparison studies where you have a watershed, you have multiple watersheds during the same time period and observations in those watersheds, and like maybe one of them remains more or less the same throughout and the other one's develop. I know some of your work in the Northeast took this approach, and I was wondering if you could maybe just elaborate or just say something about your experience here in the Front Range trying to find an undeveloped reference watershed, and kind of just what that was like for you and the challenge, and if you were able to find one.
Yeah, so I said I rely a lot on the U.S. Geological Survey stream gauges and multiple projects. And so in the Denver region, these are actually funded by Mile High Flood District, which are paying for these large set of stream gauges on urban streams. So these are tributaries to the South Platte that are not originating in the mountains. They have their headwaters at similar elevation to Denver overall. And so we wanted to find some comparison watersheds that are not mountainous, that are not developed in as urban, have low urban development, are also not in a completely different kind of slope and precipitation and elevation class, so not mountain headwater, not mountain watersheds. And also, we didn't want them to be irrigated agriculture areas either. And so this really eliminated all the U.S. Geological Survey stream gauges, because watersheds that aren't urban, that aren't in the mountains, and don't receive agricultural irrigation generally aren't flowing. And so those are very low priority to monitor, because the cost of monitoring stream flow, it costs money, and one of the motivations to put in that money is to look at water availability. And if you really have, just zero flow for most of the year, that's not a big area for water availability. So we are pursuing our best comparisons right now are in the Rocky Flats Department of Energy site, and also it's also part of the National Wildlife Refuge at Rocky Flats. And so the Department of Energy has been collecting stream flow on these watersheds. They were part of this remediation site, so there was some development there and is some development there, but it's largely a grassland area that is, they're relatively small compared to our other watersheds, but those are our best grassland comparisons. Without those, we would really be completely lacking any grassland comparison watersheds.
Awesome. I think you can still hear me. I've noticed my video's frozen a bit, but yeah, I think that's so illustrative of the region that we're in here, and the diversity of the mountainous watersheds and all that agriculture and all the urbanization. It's a pretty dynamic kind of region to be working in, I think.
Mm-hmm.
Yes, lots of water movement.
Yeah.
Human affected water movement.
Yeah, exactly. I guess maybe just one more kind of follow up while we're on this topic is, we're really focused on kind of technically addressing the challenges, but it seems like more and more it's becoming important to consider governance, and how do our technical approaches and kind of the research aspect of it, where does, I guess, the rubber meet the road? And I guess the question is, how do you view governance playing in to your research? How do you view that interaction between, I guess, academia and research in general, not just academia, but governance, and what, I guess, ideally, what do you hope that relationship kind of turns into in the coming years? What do you think it should look like?
Yeah, so this is an ongoing process for me to try to understand what needs local and state water resources agencies have, and what what these, you know, they might be more immediately focused on solving day-to-day problems, but to try and understand at a deeper level what might research, what questions they have that they can't answer immediately, and they might not be paying attention to because it's a longer term, maybe a multi-year, 5-year project, but what could really be of service to, you know, and from a research angle, come in and address something. And it's an ongoing process because our timeframes are pretty different. You know, having a multi-year process to get an answer is just slow compared to people not in research. And so to even understand what types of questions people have that are on that time frame, that are, you know, that would be more kind of like not solving an immediate problem, to not have that expectation of solving an immediate problem, but having a, you know, something. I mean, research really has a pretty specific niche within this, which is providing knowledge, and that's only one small part of the governance challenge. You know, so a lot of it is trying to apply existing knowledge and work with different stakeholders to try and balance priorities in a way that's acceptable, you know, which I don't feel like I'm not a researcher who works on those kinds of challenges, on how to best meet these multiple needs. My role, I see it so far as trying to identify places where new knowledge can contribute, which actually might be pretty, you know, limited, because that's not always the main problem. The main problem might be really conflicting needs and inertia, you know, and all kinds of other challenges. But yeah, to really listen into conversations and dialogue to see what types of things might be helpful to work on to create that new knowledge. And so I've been starting to do that in sending potential proposal topics and initial drafts to people I've met and interacted with in local and state agencies, and getting some feedback on the direction and potential areas for collaboration. Would this be helpful to this agency, or would this actually, the alternative is, you know, would the information, that this knowledge that's being created, in some ways, it has the potential to be a detriment to some people too, depending on what you find. And so, yeah, but that's, I think that's one of the fun things about working in environmental water resources, that this is, we're working with society and people, and this is supposed to be in the service of people, and, you know, so this is something we need to not do in isolation. This is not something, I'm hoping the new students like you all will be better trained to do this, because I really was not. I'm learning this right now on how to work with people who aren't researchers.
Yeah, that's actually a great segue into this. Next question we planned on asking you was if you had any wisdom or advice that you'd like to deliver to undergraduate students. They could be, you know, currently in engineering, or like you were in a natural sciences discipline, but maybe thinking about pursuing engineering in the future. Do you have any advice or encouragement for those types of students?
Advice, I guess encouragement would just be, there's so many problems to work on, and so we have a lot to do, and to try and you know, what you're going to be working on right now, you're not going to necessarily keep working on that forever. You're going to be working on different things over hopefully a long career. And so the types of people you're going to be working with, you might think, you know, especially for undergraduates. I mean, I'm teaching an undergraduate class right now. We're very focused on really kind of technical content, calculations, and that information is really important. And there are all these other fields that water resources intersects with that also have really critical contributions, and to keep your mind open to what, you know, all these other fields, how the value that they're providing, you might be able to learn from them. So in this textbook that I'm using for class has all these case studies about how people might get into ethical challenges, or how this work might intersect with anthropologists, or this book doesn't talk much about environmental justice, but there's where, yeah, just you'll be, I think you'll be working with a wide range of people over your career, and not just doing calculations. So that might be a downside for some people, that might be a plus for some people.
Yeah, it seems like we're learning more and more that it's beneficial for us to sort of expand out of our silos, if you will, and sort of flex those interdisciplinary muscles and learn how to talk to people with different technical skills than your own. And it's a really a cool feeling when you can get a team together of experts from different subdisciplines, and, you know, put a problem in front of that group, and each person kind of throws in their perspective on, you know, how to best address it. And obviously we can see in our world today that a lot of social justice issues, things that anthropologists study, so the social sciences, you know, we're not removed from that in engineering. Maybe like as we maybe have thought in the past, and a lot of the technical solutions that we design and come up with, there's always that component of how does this affect society, and how does it affect particular groups specifically. So the more we can learn how to talk to other people about that, and even be told that we might be in need of improvement, I think is a good thing.
Yeah, to be humble and say just because we can calculate an answer doesn't mean that's the best solution for people. Like, we can use numbers, but that doesn't mean we can solve all the problems by ourselves. That's really an overstep.
Definitely. So I guess staying on the same page, we're going to kind of start wrapping up generally, just like last couple of wrap-up questions. If someone listening wanted to learn more about you and your research, what are the best ways to go about that? Are you, you know, on Twitter? Do you have a website, that kind of thing?
Yeah, the best way would be to go to my website, because I post new papers and links to talks on there. And so that's, and I also have my email and my Twitter handle on there, so you can get some ways to reach me. But that has summaries of different projects that are going on and updates on there. Yeah.
Very cool. And if someone was interested in learning more, what's the best way to kind of contact you, if that's okay?
Yeah, it would be great to hear from people interested in learning more. So it would be my email, which is my first name dot my last name at colostate.edu.
Yeah, we should be able to link your email and link to your website in our podcast info once we get that off.
Okay.
So the title page of the podcast you're currently watching should have hopefully email and maybe Twitter and website and stuff like that. Cool. So yeah, thank you so much for speaking with us, Aditi. We really, really appreciate it. And I've really enjoyed it. I think this has gone really well. And I guess any closing thoughts or remarks from either one of you?
I'm looking forward to seeing what other people answer these questions.
Me too.
Yeah,
what about?
thanks for having me.
Yeah, absolutely.
A lot of fun.
Thank you, listeners, for joining the Environmental and Water Resources podcast in the Civil Environmental Engineering Department at Colorado State University, brought to you by EWRI-CSU. Be kind to each other out there, and hopefully we'll see you soon.
Bye.
Bye.